On this dot, well, I'm supposed to be trying to follow the asymptote on the left side of the dot, which means it's going to have to crawl along here and follow the asymptote. And we know it does not cross, so we know it's going to follow along the top of the asymptote. And then the option for the top one is it could go down, but then we'd be crossing that slant asymptote, so it can't do that, which means we got to go up. Okay, and then on our next point. Well, for the left side, we could go up and cross, but we know we don't cross, right? So that means we have to come along here to follow that asymptote. Then finally, from here, we do not cross our slant asymptote, so the only option is to follow along from the bottom of the asymptote. Okay. And for these graphs, you can go ahead and check them on desmos.com to see if you are graphing them correctly. Good way to check your work, but make sure you show all of this before, and then just check your work after to make sure you're getting your answer correct. All right, I think this is the last page for this one. So let's see. Missing points or holes. Okay, so this is an interesting one. So you might have something that looks like a nice rational function. But when you factor, you might notice that you could cancel one of the terms or one or more of the terms. Okay, so when this happens, our graph will actually end up looking very different. Okay, so if you can cancel something, that is going to be called a hole, and we'll get a look at that. All right, so first things first, as we always do, we're going to factor. And look what happens. When I factored, I noticed that these two are the same. I could cancel those factors out. And then I'm just left with the equation y equals x minus 2. Okay. So this means that we don't have a vertical asymptote. Okay. Though in our domain, we still cannot have negative 2. So for our domain, negative infinity to negative 2, we still have that restriction. We had to take out negative 2. But we don't actually have a vertical asymptote there. Instead, we just have a hole. So when your factor from the bottom cancels, you still take into account that factor when you're doing the domain. But if you're looking at if there's a hole or a vertical asymptote, if it canceled out, it is not a vertical asymptote. Instead, it is merely a hole. So no vertical asymptote, but we have a hole at the point. Okay, we have to figure out what this point is. We know that the x value is negative 2. How do we find the y value? Well, we have our equation right here. Y is going to equal the x value minus 2. So negative 2 minus 2 will be negative 4. So there we have a hole at negative 2, negative 4. Okay, let's go ahead and find our intercepts. Okay, so 1, 2 intercepts. Let's see. X-intercept. Set y to 0. So x is going to equal 2. Y-intercept. Multiplying, cross-multiplying. So, just realized I totally used the wrong function on that one. Oops, okay, so when you're finding your x or y intercepts, remember, use the new one you use after you canceled out. Great teachable moment here. Do not do this. Use the new one after you've canceled. All right, it would have been so much easier. Boop, right there. Okay. All right. So this one's graph actually ends up looking very different than a rational function. So we have the line y equals x minus 2. So we would normally have all these little asymptotes going on, but when I graph this, it actually ends up looking very different. Okay, so it looks very, very normal, but at -2, -4, we have a hole in our graph. So instead of a vertical asymptote, because the two factors canceled out, we don't have a vertical asymptote, but instead we have a hole. And that right there is our graph. All right, next one. Example 8. Okay, go ahead and try to graph this one. See what you get. All right, so let's see. Factoring. We have y equals x over x times x squared minus 4. Ooh, the x's cancel. That means we have a hole, so no vertical asymptote. We have a hole at 0. What else? Oh, interestingly, actually, we are going to still have a vertical asymptote because this other bottom factor did not cancel out. So we're still going to have a vertical asymptote. All right, so figure out what point this hole is at. Let's plug in 0. So plugging in 0, that goes away, and we'll be left with a -4th. All right, I have no idea why I wrote that in red, but oh well. All right, so vertical asymptotes. Well, let's find our domain first. The domain, when I factor out the bottom, we know we cannot use -2 and +2. So the domain of y, taking out -2 and +2, but everything else remains. All right. Okay, so my vertical asymptotes are going to be the lines x equals 2 and x equals -2. Horizontal asymptote, let's see. Well, the degree of the top is smaller than the degree of the bottom, which means we'll have horizontal asymptote of y equals 0. Okay, let's go ahead and try to find the intercept. So x-intercept, set y to 0, and solve. That's going to be, let's see, cross multiplying. Oop, not a true statement, so we do not have an x-intercept because 0 does not equal 1. Let's try the y-intercepts. Setting x to 0. Oops, got to use the original one. Not use the original one, got to use a simplified one. It's going to equal 1/4. But, sadly, that's where my hole is at. So it's actually going to be a hole and not a y-intercept. Okay? All right, let's go ahead and graph these. Okay, graphing our vertical asymptotes at 2 and -2 and making sure to label them. And let's see, horizontal asymptote at y equals 0. Any points? Well, we have a hole at 0, negative fourth. We know that much. But we don't know anything else. Interesting. All right, so I have 3 sections of my graph to look at. On this left-hand section, I have no idea where to start. I don't have any points. So that means I'm going to have to find some test points. All right, let's see. Picking a value on the side, let's do negative 3. Negative 3? Well, you know what I can do? Because my horizontal asymptote is the x-axis, I can just check the sign of my answer to see if it should be above or below. So we can only check the sign if your horizontal asymptote is y equals 0. If it's not, you need to actually know the actual value for y. But because my horizontal asymptote is this line, I can just check if the answer would be positive or negative. So plugging in a negative, that would be a negative on the top, divided by, well, negative cubed is still a negative, minus 4 times a negative, that's going to be positive. So negative 3 cubed, we're going to actually have to solve out that one on the bottom. Oh wait, I was looking at this one. I need to be looking at this one. We'd have a positive on the top, sorry, we gotta look at this one. Positive on the top, and then a negative minus that's gonna be negative, negative again. That's gonna be positive. So it means they're gonna be up on the top. Some value here, and our graph's gonna go up because we don't cross, and down. Actually, you know what? I didn't even check to see if we have a cross touch point. How terrible. We were supposed to check that. Let's check the cross touch point. So cross touch point, setting our horizontal asymptote equal to our function. It's going to be 0 equals 1, which is not true. So, you know what? We don't actually have a cross-touch point. Okay, good thing. Whew. So we don't have a cross-touch point, so we don't have to worry about that. So same thing happens, what I said earlier. We know what's going to be in the top, and it's not going to be crossing the horizontal asymptote, so it's just going to skim along the top, and it skims along the vertical asymptote from the right. So for this point, it could go up or down. We know it can't go up because it would have to be crossing the horizontal asymptote. Therefore, it must come down. All right, on the right side of this dot, we could go up, but that would mean it would be crossing the horizontal asymptote. We can't do that, so it must come down. All right, and then on the right side, I do not know if it should be in the top or the bottom. So picking a value, go with 3. Plugging that into our original function, not original, sorry, our new function. Positive on the top, and then positive, positive, which is also going to be positive. So my point is going to be somewhere around here. Go up and across. All right. So that is it for 3.6. You have your written homework, which is going to be due by the end of the week. Please email me if you have any questions.